Welcome to part 1 of Competency 4. In this competency, the teacher understands and uses reasoning to identify, extend, and analyze patterns and understands the relationship among variables, expressions, equations, inequalities, relations, and functions. The competency is part of Domain 2, which is 21% of your test. In this video, we will apply algebraic patterns and sequences. Before we begin, let's note the two types of sequences that we are going to use in this video. You have the arithmetic sequence, which is noted, you see the formula, and note the difference between this sequence on the left, the arithmetic, versus the geometric sequence on the right. Notice they both are going to utilize your A1, which is your initial term, your first term. Then the N for the nth term, the term you're looking for, that you're concerning yourself with probably, that term is used in both, but very differently. Then look at D and R. Well, D is the common difference. You're going to subtract to find that. And then R is the common ratio. So you're going to do some dividing to find that. Take a look at those. Stop the video. You might want to take a quick little snip of this on your phone so you can work along with me. Okay. Number 1. Given the sequence of numbers 1, 1/2, 1/4, 1/8, 1/16, and 1/32, what is the general formula and next term of the sequence? Okay, for this particular situation, don't think of the formulas that I gave you prior. Let's see if we can't just be reasonable and figure this out. Let's go from this not general, but this specific situation and go back to the general. Okay, so let's see what we can do here. And I do believe that's called inductive reasoning, but we might want to look that vocabulary up. Okay, this is what I'm going to do. All right, I have created a grid because we're looking for the nth position. Okay, so number 1 is in the first position, and 1/2 is the second, and then the third, fourth, fifth, and sixth. Okay, and so on. All right. Now, if you're looking at the values and you're thinking, well, we have 2, then 4, then 8, well, that's just 2 times each one times 2, each position. Well, number 1 breaks that down. You could say, well, 2 times 4 is 8, and 2 times 8 is 16. So you could see each one of those, but it doesn't work. Each one times 2 is what I mean. But no, because we're looking at the position. So we would have to say 2 times 1 is 2. Well, that just doesn't work. So let's look at number 1. How could we display 1 or show 1 to where it, let's say, fits in with the sequence? It is consistent with it. Well, we know that 1 over 1 is equal to 1. Okay. Well, the numerator of 1, it definitely is consistent with the entire sequence. So we can leave 1 as is. But now we have a conundrum. We have the denominators. We have the number 1. Okay. Well, then we have 2 and 4. Well, let's look at the position. The position of 1 is 1. Well, 1 times 1 is 1. But that breaks down when we go to the next position, position 2. Well, when we're in position 2, we have 1 over 2. Okay? So we need 2, the number 2, but we also need to incorporate n, which is the position. And if you can't see what's going on, let me help you out. Let's think about this. I see 2. I need an n. And you can look at your options. They have 2 to the n, 2 times n minus 1 in B. I'm going to disagree with that, okay? I'm going to disagree with B. And I'm looking 2 times n. We just discussed that. So that's not going to work. So B and C. Now look at the next term that they have, that because part of the question is next term of the sequence. Okay. Well, if we go on and if we're looking at it as 2 times 4, 2 times 8, 2 times 16, well, 2 times 32 would mean that the next term is 1 over 64. If you saw that, I agree with you. Okay. Well, that gives us a yes on A and D. But now we've got an issue. Let's look at the denominator that A has, okay? They say 2 to the n. Well, what will that give us? Okay. So that would give us for the second position. Well, no. Let's not even look at that. Let's look at the first position. If we use 2 to the n, we would have 1 over 2 to the first. That doesn't work. Oh, but it works for the second position. It works over here. That's perfect. That's a little suspicious. So I disagree with A. But now let's look at B. All right. So let me erase this here and write this out again. What if we did that? We said 1 with 2. Well, n is 1, and 1, oops, I meant to write 1. Sorry about that, because we already have the formula on D. We're looking at D. We're going to use it. So 1 minus 1. Oh, well, that's 2 to the 0. Okay, and we should all know, sidebar note, 2 to the 0 power equals 1. 2 to the first power equals 2. 2 to the second power equals 4. Oh, so that's helpful. It's not what we want, though, because that's what A did. But now, if you have n minus 1, I agree with that because that would give us 1 over 1 because 1 with 2 to the 0 obviously equals 1. So I totally agree with that. That works. So looking at that, you're saying, okay, you've eliminated everything else. Obviously, you think it's D. And I could sit here and write all those out. Oh, we are not going to do that. Let's use our calculator. This calculator gives us exactly what we need. You're like, well, where does it? Let's look at it. It'll set the whole thing up for us. Okay, so use table, clear it out, put your fraction in, and put in your formula for D. However, you must use n equals x. Okay, so we have to use x. And if you look down at your variable button, we have x, we have y, we have z, we have k, a, b. We don't have an n, so either way, we're going to have to substitute that. Okay, so we know we want 1. All of my numerators are 1. Okay, so we are going to say 2 and then carry it up, and then that gives me the exponent. So it will be x minus 1. Make sure it's typed in correctly because sometimes you might hit things wrong. So I like it. Now, let's push enter. So it's in. Let's start. It's starting at 0, but let's not start at 0. Let's start at 1. Start at 1. Obviously, we need whole numbers. Okay, we should be okay with whole numbers. Let's see what's what happens, okay? So, okay, let's keep going. All right. Well, look at what happens. I see 1/2, and then for position 2, yeah, position 2 has a half, position 2 has 1, position 3 has 1/4. That's correct. Let's keep arrowing down. Oh, look, it's exactly what we needed, and it should be 1/64 next. That is our prediction. So that's all perfect. Now let's go up and just kind of see what happens with the negative. Look at what the negative values do. Now that is a whole other situation, okay? But make note of them because you could be asked questions like that. As you see, if they started with 64 and went the other direction. And you notice they're not using fractions. 64, 32, 16 gives you an idea of another little section of the sequence you could be given, and you would have to come up with that. That's more difficult. But I've seen it in a question, and I have had to deal with that. Now, we have verified our option D using our calculator. Okay, now let's move on to number 2. All right, number 2 says, given the sequence of numbers 1, 3, 5, 7, 9, what is a general rule for the sequence? Okay, those are all odd numbers. Okay, now looking at what's still in the calculator, we're kind of looking at that, and I'm not thinking that's going to work. And even if you look at what we just talked about, 2 to the n is similar to that. 2 to the n, we saw that a moment ago. I don't think that's going to work either because I have that over here as a sidebar. See my sidebar? Okay, that would be 2 to the n. Well, I don't see that see, as 1, 2, 4. Well, that's obviously not the same thing. So let's eliminate A. Now, n squared, that would be like x squared. That's your quadratic equation. Okay. No, that would be 2 squared. It'd be like 1 squared is 1. 2 squared, that's 4. 3 squared is 9. 4 squared is 16. So those aren't the right numbers. So I'm going to get rid of B. Okay. Now, I'm going to look at C. Let's put C in our table and see if we can't come up with the same thing. Okay? So let's go second. Let's get out. Let's go back to our table, clear the whole thing out, and say 2x minus 1, enter. Let's start at number 1. Okay? And let's just see what we get. Ooh, looks very promising. I see 1, 3, 5, and then 7, 9. I agree with that. However, let's not stop there. Okay? Let's look at 2 minus n, just to look. Okay? I disagree with it. It's not what we want. C is what we want. However, doesn't hurt to play around while we have time to do that. Of course, during a test, we're not going to have time for that. So I went back to the beginning. I'm going to clear it out. So let's say 2 minus x. All right, let's go enter. Start at 0. No. Start at 1. A good thing we can delete and type over. There's our 1. Okay, and push enter and enter. Okay, very interesting. Look at what it gives us. I see 1, 0, -1. See how it keeps increasing with negatives? As my x becomes more positive, my y becomes more negative. That's pretty interesting. And then as we go the other direction, as my x is negative, you could think of it as, okay, it shifts it over and then it reverses the role of positive and negative. This is something important to note because when you're dealing with sequences, you will see questions that give you that very sequence. It's a great way to come up with questions for students, okay? So let's mark out D. D wasn't what we wanted, but it's definitely worth investigating. So you might want to play around with that a little more. Okay. And that also clues you into why they gave you those particular options because they're all very important sequences used often and are often either given in the problem or they're an answer. Okay. All right. So that being said, let's go to 3. I see some more familiar items in 3. What is the rule that would determine the nth term of the sequence, the term of the nth sequence represented by the illustration? Oh, that's a tongue twister. Okay, we got past that. Not a problem. But let's look at what we have in our image here. Okay, I see my figure. That is my nth term, 1, 2, 3, 4. But then my actual values are 2, then 4. I'll write that 2 up. Let's be consistent here. We have 2, then 4, then 6, then 8. Okay. Well, it looks like to me in this situation, we can say n times 2. So n is 1. 1 times 2 is 2. That's correct. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. So I would say 2 times n. So that would be D. So you can put that in the calculator. Double check that. I'm sure it will give us our even numbers. We'll do it anyway. So let's see if we can clear out. So yes, there it is. There it is. I'm going to clear it all the way. Push clear enough, you go backwards. So remember, we have to do 2x, not 2n. Okay, limitation of our calculator. All right, so push enter. And let's start at 1. No, 2. We're starting, see, I did it again. Starting at 2. There we go. I should have arrowed back and typed over. I didn't, or cleared it, whatever. Okay, push enter, enter. Gotta push enter a lot. Here we go. Okay, 2, we have 4, 6, 8. Oh, let's go back to 1. 2, 4, 6, 8. There we go. Exactly what we wanted. Now, you could enter the others in the calculator, especially A and B, just to think about what would that look like. It's going to shift your number line, one way and then the other way. Okay. Always worth looking at. All right. So these are not our options. C has been verified. Okay. Let's go to number 4. Number 4. What is the rule that would determine the nth term of the sequence represented by the illustration? Okay. So with figure 1, we have 1 star. Figure 2, we have 4. Figure 3, we have 9. Figure 4, we have 16. All right. So let's create our little table here. That's pretty sad. Okay. That's a little better. Not much. Okay. But that's our n. So each of our figures, that's n1, n2, n3, n4. Okay. And then our values are here. Let's see if I can do better. All the way. So our values are, oops, looking at one thing and writing another. Okay. So this is 1, then 4, then 9, and then 16. By looking at these arrays, you have probably already noticed something that's going on. I see 1, but then I see 4, which is 2 times 2. You should recognize that. It's either 1 plus 3, okay? But that doesn't work out because we have 1. Well, 1 times 1 is 1, but 1 plus 1 or 1 plus 0 maybe doesn't quite make sense. But if you look at N2, I see 2 rows and 2 columns. So if you're familiar with arrays in school, I'll just get rid of that. I was going to do times, but that's not helping. If you are familiar with arrays, go way back from school, whenever, or if you've recently been in college, you will note that you'll see it and you'll recognize it. So then on the third array, that gives us 3 times, we have 3 here, 3 here. And then on n equals 4, figure 4, 1, 2, 3, 4, and then 1, 2, 3, 4. So 4 rows, 4 columns. So suspiciously for me, that means my n is squared, which would be option D. Okay. Well, and we just discussed it can't be n plus 2 or n plus 1 or n plus 2, which I just talked about. Because let's go back to number 1. Okay. That automatically gives us a counter example showing that it doesn't work. So that would be 1 plus 1. That would mean I would have to have 2 dots, and I don't. And then look at B. That would say I would need 1 minus 1. That would be no stars, not dots, but stars. I would have no stars. So that doesn't work. So A and B are obviously out. And then I look over here at C. Well, that would mean I have 2 times 1 is 2. Well, I don't have 2 stars in position 1. I only have 1. So after I go through that process elimination and my logical explanation, I use what I have in my image to use my induction, my inductive reasoning, and I'm like, okay, has to be n squared. Well, naturally, we already know this. If you've done anything with quadratic equations, you probably saw that very quickly. But we can always type all of these in and see if it ends up with 1, 4, 9, and 16 in our sequence, in our list on our calculator. Okay, so let's clear that out. And let's say x squared. Remember, our n has to equal our x. All right, push enter. I want to start at number 1. You got to push enter until we go. Okay, there we go. 1, 4, 9, and moment of truth. There's our 16. And the next one is 25. 5 times 5 is 25. So we could even predict the next one. We would have 5 times 5. That would be 25. So verified, option D. All right, now let's go on in our writing they've given us here, our, our information. This was at the beginning of the video, okay? And there are other forms ways you can write this out. I'm talking about your sequence here, your arithmetic sequence. I like to just use this formula and think it out like this because I can always subtract to get the D right here. And I am going to know my first value. Okay, now remember, I know there's a lot here that they're giving. They're giving you 2 forms. But remember, that is always looking for the nth term, whatever that is. Either they may give it to us and ask us what n is. Either way, remember that that's what it's equal to. Okay? So we have 1, 2, 3 important things. If I can get those 1, 2, 3 things, figure them out from my sequence or from the information given, I can use them. Then I should be solid. Okay. And I have my calculator to help me out. All right. Number 5. What is the 90th term of the sequence 2, 6, 10, 14? Okay. Well, we have right here, well, we know A 90, that means AN, that's our 90th term, and we know N equals 90. So we have that, all right? And we want to figure out what is that value of the 90th term, base of 90, okay? Well, we know that A1, which is your initial or first term given, is 2. Now we need to determine, what do we have? Do we have a common difference or do we have a common ratio? Well, obviously, by looking, we have a common difference, which would be D. Okay, I'm going to, here, I'm going to move stuff. I'm going to move this so we don't get things mixed up. And let's do this. The difference from 2 to 6 is 4. 6 to 10 is 4. 10 to 14 is 4. So obviously, our common difference is 4. So we know that E equals 4. And we are looking for A, the 90th term. I don't know if I did that justice. That's better. Okay, so I need the first term, which is 2. Then I need a plus. Then I need my common difference of D, which is 4. And in this situation, okay, I have 90 minus 1. And I can put all that in my calculator and figure it out. Okay. Now I could put in n where the 90 is and put it in the calculator and get more values to see if I can predict out my sequence to make sure it's right. But I'm good here. So let's put it in, see what happens. I'm not going to do that in my head, right? So 2 plus 4, 90 minus the 1, push enter, and that will be option D, 358. And it is verified. Now you could put uh 2 plus 4 and minus 1 into the calculator also, as I said, and get other values. All right. So let's move on to number 6. What is the 25th term of the sequence? 15, 13 and 2/3, 12 and 1/3, and 11. Okay. That looks a little dicey, but don't worry about it. I'm not seeing a common ratio. I'm only seeing a common difference. But you need to put it in the calculator and verify that. Okay? Okay. So let's try this. So 15, now it's a common difference. So you need to subtract. Subtract, and remember that's a mixed number. So you say second fraction to give the mixed number version. Set up. So 13, arrow over 2, arrow down 3, and that's 4/3. And go ahead and leave it in that fraction form. I find that it's a little easier to deal with, okay? So looks like this is what we are subtracting out each time, okay? Now, let's go back and let's put in that 13 and 2/3 again. Make sure you arrow all the way over. Now we are subtracting 12 and 1/3. Okay, so again, we're going to need our mixed number setup. 12, 1 over 3. Okay, and enter. And yeah, looks like the difference is 4/3 each time. So this tells me that D equals 4/3. Okay, that's good. So what can we do? Well, let's go ahead and just put everything in the calculator. Okay. All right. So let's clear it all out. And we know that the first value that we need is 15. Okay. My first value. Okay. But my D is actually negative 4/3. So what do I need to do? I need to say minus. And the reason I'm using minus and not the negative button is because 15 is a number. And if I'm using it with a number in front, I can say subtract. Okay. Now fraction, and that's 4/3, arrow over in parentheses. Okay, n is equal to 25 right here. Okay, so 25 minus 1, close the parentheses, push enter, negative 17. And I know for a fact that is the correct answer. So we're good. All right. Let's try number 7. Okay. In a certain arithmetic sequence, the first term is 23. So I'm going to sidebar over here. So A1 equals negative 23. Okay. And the 19th term, okay, so A of 19 equals 5.8. What is the value of the common difference? So we're looking for D. Well, that's really not tough to find, okay? We already know our answer, our A of 19. So put 5.8 here equal to, okay, our first term is negative 23 plus D times, now we know what N is. It's 19. 19 minus 1. And they told us the type of sequence, so we would know the proper formula. Okay, here, my 19 looks a little weird. That's a tiny bit better. Okay, so let's see. The first thing I would do is I would say plus 23 on both sides. Okay. All right. So now I'm going to write this out. I'm going to go back over here and let's write this out so it makes sense and you'll see what I'm up to. Okay. The first thing is negative 23 plus 23 is 0. Okay. So let's write out the left side. 8.5 plus, oops, 23, 23, 23, okay, is equal to, and I have my D, and 19 minus 1 is the 18. Now, what do I need to do? On both sides, divide by the 18. Well, what does this do for me? Well, that equals 1, so it goes away. This gives me something very solid to put in the calculator and I get my value. Okay. So let's go ahead and set that fraction up and I get 5.8 plus 23. Go down and divide that by 18. Notice I didn't do step by step calculating. I went through and I followed through algebraically. Now I'm going to put it in the calculator. I'm doing it once, saving time. My process is correct. I know my process. I don't mess with the numbers. Now, I did go follow through with 19 minus 1 because it's Captain Obvious. Okay. All right. You could have left it, but it was pretty obvious. Simplify how this looks. Okay. Now let's push enter. And the common difference is 1.6. I absolutely believe that. Okay. Okay, next we're going to look at geometric sequences. Now, I'm not going to go through everything with you. The most important thing to generally remember is that you have a couple of good formulas. All right, let me change my highlighter here. Okay, and the most important one is this one. Okay. And let me write that in a different way. Usually you'll see this. You'll see the A on the outside of the parentheses, then the common ratio in parentheses, up to n minus the 1. Okay? Doesn't matter how you write it, but that's how we see it. Okay? All right. And the first version, I've seen that some, but it doesn't come in as handy as the second one. Okay. All right. So let's look at number 8. Oh, and here's some examples if you want to pop those in your calculator and work with them. Feel free to do so. All right. Okay. we have number 8. What is the 10th term? N equals 10 of the sequence 2, 8, 32, and 128. Okay, we know we're in geometric sequences. And for geometric, we need a common ratio. And this is what we do to get our common ratio. We look at the first two terms and we say 8 over 2. And then that should equal 32 over the 8. And then from there, we should have 128 over 32. And these should all equal the same thing. Okay? So let's look at our calculator. 8 over 2. And I know you can see that that's 4. Well, then that means in the end, every single one of these, all of these, even if the sequence went on forever, every time we did this, second term divided by the last term, next term divided by the last term, next term divided by the prior, it should all be 4, equal to 4. Okay, so let's set up a fraction in 32 over the 8. It's 4. Another fraction, 128 over 32, and it's 4. Okay, well, the 10th term, so what are we looking for? We're looking for a to the 10 equals. We know what our a value is. That's 2. We know what our ratio is now. That's 4. Then we know what n is, so that's 10 minus the 1. So we just need to put that in the calculator, okay? So 2 in parentheses, 4. I can close my parentheses, or I can go ahead and say caret up 10 minus 1. And yes, I know that's 9, but I have a habit of, because I get tired, I always, during a test, my habit is to put in the calculator basically what I see. I'm just going to move my parentheses over. Either way, still the same thing. And not only that, I'm not going to do 10 minus 1 in my head, okay? All right, now let's push enter, and there we go. Option C. All right, let's look at number 9. What is the 30th term of the sequence? And here's our sequence. All right, we're working with geometric. So we know that we have to create a common ratio. Even so, and can I point this out for number 8 also? If we had subtracted, you can see right away we're not going to have a common difference. And that always clues us in to maybe we have a common ratio. Okay, well, let's see what we have here. Well, I see 45 over 90. Ooh, well, that's a half. Well, let's check the next one. We should have 22.5 over 45. Now that should equal a half. Let's check and see if it does. Okay, let's clear some things out of here. Set up a fraction, 22.5 over, okay, 45. We're checking the second one. Okay, it's a half. Definitely a half. Okay, so we know this is 0.5. Well, let's make it 0.5. Okay, so then we have A is 90, so we have 90 times, well, 0.5. I don't need that 0, but let's go with it. 0.5, and then we have the 30th term, so we need 30 minus 1, okay? All right, I'm writing it this way so you see that you cannot multiply the 90 times the half, okay? If you do that, that's a huge error. You will not get what you need. All right, that being said, we have 90 parentheses, 0.5 caret up, then I have 30 minus 1, arrow over, close my parentheses, push enter. Oh, goodness gracious. We will need that scientific notation. Okay, not a problem. You just follow along till you find your very first whole number that's not zero. So we need a decimal after that. So we need 1.68. Well, that eliminates A and D. Okay. Now we need to decide, do we need 10 to the 7 or 10 to the negative 7? Okay, let's see. Well, I always like to think of, well, what did it take me if to get from where it's properly where I need it to be to back? Well, I'm thinking negative 7, but I could be wrong. So what do? We test our theory. I very well could be wrong. So 1.68. Now remember to use your magic button here, the scientific notation button right here. Okay. It puts everything in, and let's put negative 7 and enter. Oh goodness, I didn't push anything right. Okay. I was sitting there talking, I put in 1 and didn't put in anything else. 1.68. Now use your magic button. Oh my, talk about getting tired. So negative 7. Now let's try. Ah, there we go. Now we have what we need. So it was negative 7. Sometimes I'm wrong, sometimes I'm right with those kind of things. It's easy to get facts backwards when you're taking a test. So this is a situation where you definitely rely on your calculator and make sure you put everything in correctly. Okay, that's the last question in this video. I wanted to thank you for watching and putting up with a little bit of my rambling. And again, thank you for sharing and liking and subscribing. I hope everyone passes their test. So, happy testing, guys.